Okay, we've been talking about what is a zero, a solution, a root, and really it just means when f of x equals 0. So I have an f of x, and I'm just going to plug in 0, and then I'm going to be able to solve my cubic equation. And really probably the first way you learned how to solve a cubic equation is by factoring. So that's what we're going to try. It looks like we have 4 terms, so I'm going to try to factor by grouping. The first two, I have a GCF of x squared, and so it's going to be x squared times the quantity of x plus 2. And then the second group, I notice they're both negative, but even when that first term is negative, I want to factor out a negative, and a negative 4 in this case, and that will leave me with I can multiply that by the quantity x plus 2. And so that's good news because it looks like I have a big GCF of x plus 2. So I'm going to factor out that x plus 2 out of both of those pieces. And then what do I have left? I have an x squared minus 4. Now that will actually keep going. I'm going to pull it up here. So I've got 0 equals x plus 2 times the quantity x squared minus 4. Well, I notice that x squared minus 4 will factor further because it's a difference of squares. So it'll factor into x plus 2 times x minus 2. So our zeros you're going to find by just setting these factors equal to 0. So I have x plus 2 equals 0. I actually have another x plus 2 equals 0. We're going to talk about when you have multiple solutions that are the same. So really I'm going to end up with x is negative 2 and x is positive 2. So my zeros are negative 2 and 2. So we're not going to graph just yet, but you could kind of get an idea of what's going on with the graph. So I know that I would have a point at negative 2 because that's one of my zeros, and then a point of positive 2. You could always use your y-intercept. I always encourage you for another point to use your y-intercept because you can just plug that in when x is 0, and most of you should be able to do that in your head. It would be negative 8. So those are at least 3 points that I know are going to be on the graph. Now, when it talks about end behavior, I can actually know what the end behavior would look like because I know the leading coefficient right here is positive because it's 1. And I know that my degree is 3. So my end behavior is going to replicate f of x equals x to the third. So I could even think about what that graph looks like. So it's going to rise on the right and fall on the left. Okay, let's go ahead and look at number 4. How would I find those zeros? Same process. Once again, we're going to factor. So f of x is 0, and it looks like I have an x squared in common. And so once I factor out that x squared, that's my GCF. Looks like I can keep going. So I have x squared times the quantity x plus 2 times the quantity x minus 2. So my zeros are going to come from my factors. X squared could equal 0, x plus 2 could equal 0, and x minus 2 could equal 0. Well, you have x equals, normally it would be plus or minus 0, but that's only one solution. So I'm going to have 3 zeros. I'm going to have negative 2, 0, and 2. The most that I could have, the most zeros that I would have would be 4 because it's to the 4th power. But I do have 3 real zeros. And I actually have a double solution with that x equals 0. And we'll talk about when you have that solution more than one time.